All right. Section 3.0a. Variables on both sides. This is continuing something from last chapter, just as equations get more and more complex with more and more things maybe to do in order to solve for x and get x all by itself on one side of the equal sign. Let's see what happens here. So if you have a variable on both sides of your equation, you must add or subtract one of them to get both variables on the same side. So notice here that there was a 5x over here and a 2x over here. You need the x to only be on one side. And so we move this, by basically subtracting it away from this right side, and so it ends up over here on the left side. So we subtract 2x from both sides. Now the right side is just 1, and 5x minus 2x becomes 3x. The minus 2 just comes down, that's over here as well. And then we continue like normal. So, and I'll explain this purple hint as we go, but want fewer negative numbers? Then move the smaller of the two x's. Here's what that means. Essentially, I have a 5x over here and a 6x over here. If I were to do what the example said a moment ago, I would subtract 5x from both sides. So there'd be no more x's over here, and 6x minus 5x would become 1x. But compare that if I decided, how about I subtract 6x from both sides? What if I put the x's over here, by undoing the 6x? What if I subtracted 6x from both sides? Then it'd be over here as 5x minus 6x, which is negative 1x. And so this is where it comes in do you want fewer negatives? Then do this rather than subtracting 6x from both sides. So the x's are now going to gather over here on the left, because we're getting rid of that, you know what I mean? And so 6x minus 5x is 1x, or just x. Minus 2 is over there, and now the right side, there's only a positive 4. And now we go from here. We add 2 to both sides of the equation, of the equal sign, and again, 1x is just x. And so we're done. There's not going to be a need to now divide both sides by 1, because 1x is just x, and so we're done. So again, this example. See, number 2 is a great example to discuss your options, because some people really insist, and they're really most comfortable if you get the x's to the left side. If I were to subtract 5x away from the right side and gather the x's to the left side, but you're going to end up with a negative 2x. Some people, it's like their priority to not have a negative something x. And so those people would see, well, if I subtract 3x over to the right side, I'll get positive 2x. So it's up to you. Maybe I'll do it both ways real quick. I tend to be someone who likes getting things on the left. I don't care that 3x minus 5x gets me negative 2x. And what remains over here, people, is a negative 21. And then I would subtract 7 from both sides. And then we still have a negative 2x over here. And negative 21 minus 7 is negative 28. And so then I just have to divide both sides by negative 2. But I'm okay with that. And x becomes, what is this, positive 14. All right? So that's if you're someone who really, really prefers to just always get your variable on the left side, and you don't care if that means a negative something x or not. But let me real quick do it the other way. What if it was like, no, I'm going to do this because, it'll put my variable x on the right side, but at least it'll be a positive 2x because I like that better. And then you go from here. And so you would add 21 to both sides to get rid of that. And so you just have 2x. 7 plus 21 is 28. And then you would be dividing both sides by 2. And you still, of course, get an answer of essentially x equals 14, or 14 equals x. Number 3. Again, I'm just someone who likes getting my variable, so that's negative 2x. All right. And so I end up with negative 2x equals negative 14. Negative 4 minus 10 is negative 14. And then I just have to divide both sides by a negative 2. And so x equals 7. But if you were going to do it the other way, you say, hey, 5x is smaller than 7x. So I'm going to subtract that. So that way I end up with a positive 2x, and then when you go from there, you end up dividing both sides by, and you still, of course, get a final answer of 7. Number 4, variables on both sides. Now, I'm going to stop right here and just kind of interject something. These equations could be even more complicated. Like I could throw some parentheses in there and such, and so on and so forth. And for example, if there were parentheses on one or both sides of this equation, that's what you would do first. You pretty much always look to clear parentheses first and then do anything that is possible to simplify just on the left side or just on the right side. I'm talking about combining like terms, for example. But in number 4, there's none of that. But there is a variable on both sides. So we need to get the variable only on one side. 8x minus 4x is 4x. And once again, once you have the variable only on one side, now you work on getting that variable x all by itself, by getting that plus 2 out of there by doing the opposite. 18 minus 2 is 16. And then getting that times 4 out of there by doing the opposite, dividing both sides by 4, and getting a final answer of x equals 4. And that's all there is. We're taking this a little bit at a time, baby steps. That's all there is to 3.0 Part A.